0.8. Okay. The typical alpha level that we would choose is alpha is equal to 5%. Okay. It doesn't have to be, and once again, it depends. It depends on many different things in relation to what you're willing to accept the probability of committing a type 1 error, but typically we set it at 5%. So let's just leave that at 5%. And the power is, if there is an effect really there, if there really is a difference between the sample, okay, and in this case, this is a single sample test. If there really is a difference between the average of the sample and the value that we're specifying under the null hypothesis, well, what do you want to notice it, and how often do you want to notice it? Okay, is really what the power is. So what this is saying is that 95% would say, it's saying that if there is an effect, a large effect there, and if we do set the power at 95%, we should be able to observe it 95% of the time. Okay. So let's just run this here and see what we get. So we're going down to calculate here, and we hit calculate, and you can actually see that saying for a single sample t-test with a large effect and an alpha of 0.05, and if it is there, you want to be able to observe it 95% of the time, well then the total sample size is 19. Now this power level here is a very, very big power level. Let's just set that down to 0.80, which is typically what it's set at. And let's do calculate, and you can actually see that we're going down. You're reducing the power of the test. The sample size actually decreases to 12. Okay, but let's go back up to 0.95, and let's just leave it here. Let's say we make the effect size a little bit smaller. Okay, so that's going to be harder. It's a softer sound and a larger sound. So we want to be able to observe it. Let's say we make it at 0.5, which is a medium effect, with the same alpha level and the same beta level, or the same power, which is 1 minus beta. And let's hit calculate. You can see that our sample size is increased. So what this is saying here to us is that to observe something smaller, to observe something that's a little bit softer than a big effect, we require more evidence. We require a larger sample size, in this case 45. What about the effect if the effect is very small? So let's say the effect is 0.2. Okay, so let's say the effect is 0.2, and let's hit calculate here. We need 272 participants. What would an effect of 0.2 look like, I suppose? Well, what would an effect of 0.2 look like? What would an effect of 0.1? What would an effect of 1 look like? Let's see. An effect of 1, let's hit calculate. We only need 13 observations. What is an effect of 1? Well, let's think about if the average, let's say an exam, let's say our students score 60%, and we want to test whether the 60% is significantly different to 70%, and let's say the standard deviation is 10%, well then 60 minus 70 minus 60, or 60 minus 70 gives us -1, divided by 10, the standard deviation gives us 1. So if the standard deviation of your experiment is around 10%, and if the difference between the means is 10 units, well then an effect size of size 1 is what that represents. Okay, obviously an effect size of size 0.5 is something that's even half that. So 5% of a difference between two students if the standard deviation is 10%. Okay. 0.1, well, an effect size of 0.1 would be 1% of a difference between students on an exam if the standard deviation was 10%. Okay, that's what's going on here. So you know yourself to observe. If you had two students standing in front of you, and if you want to figure out who's the best on an exam, and if the real difference between them is only 1%, for you to be able to observe that particular effect, well, you'd need to ask 1,000 students. You'd need to work on 1,000 students, 1,084 students to observe such a small effect. So you'd actually see in this situation that the effect size is actually something that really influences the sample size that we need for our experiment. So it's really important that we have an estimate of the effect size. If we go back to 0.2, which is a small effect, and we hit calculate, we need 272 participants. So if you know that your experiment has the differences between the let's say the groups is small, well then you need a lot of participants. Okay. So what about, this was a one sample test, what about if it's an independent samples test? In other words, we have males and females, we want to check the difference between them. Well, everything remains the same. Okay. Actually, let's go back here to the single sample test again. Okay, the single sample test. That was a one-tail test. Okay. If we want to set it as a two-tail test, in other words, we just want to find a difference, larger or smaller, we don't care. well then you need 327 participants. For a medium effect,